Okay guys, in this video we will wrap up 10.2. We'll do a quick and dirty classical approach problem, and then we will do one with a p-value approach. So in a Gallup poll, a random sample of 805 adults were asked to identify their favorite seat when they fly. 442 chose window. Use a 0.05 level of significance to test the claim the majority of adults prefer a window seat when they fly using the classical approach. Okay, first let's verify this is a simple random sample. Majority means greater than 0.5, so we assume p is 0.5. 805 were asked, so 805 times 0.5 times 1 minus 0.5, which is also 0.5, is 201.25, which is definitely greater than or equal to 10. So the sample size is less than 5% of our total population. I think that's fine. What's our null hypothesis? That only 50% of the people, or 0.5, is our proportion who prefer the window seat. Someone wants to know if it's greater than that. The majority means that greater than 0.5 prefer it, which this is a one-tailed test. It says alpha is 0.05 significance level. So what is our test statistic? P hat. It's what happened in our data. So that's 442 out of the 805 people said they preferred a window. That's 0.549. Okay, what is our standard deviation? That's the square root of this is the denominator here. 0.05 or 0.5 times 0.5 over 805. And when you put that into the calculator, you get, by the way, that's an 805 and not an 085. Should be an 8 and a 0. This is approximately 0.0176. Now, to compute my test statistic, I will take my data, 0.549, minus 0.5 over 0.0176, and that is approximately 2.78 is my z-score. Now, let's draw a picture of that. We need 0.05 significance level. But unlike the two-tailed test, my entire 5% is now on the right side. That means I'm looking for a z-score where 95% is on the left side. If I look at my critical value, that's similar to the critical value for a 90% confidence interval. This is 1.645. So I'm comparing my 2.78 to 1.645. I ask myself, is the 2.78 going to be in the shaded region? So is it bigger than 1.645? Yes. What does that mean? If we're in the shaded region, we reject H naught because we have enough evidence. And our conclusion is there is sufficient evidence. Remember, our conclusion will talk about our alternative hypothesis. There is enough evidence to conclude that a majority of adults prefer the window seat. Now, we're going to do a problem and some examples from a p-value perspective. The p-value perspective, all of these steps are exactly the same. The only difference is instead of taking my z-value and comparing it to another z-value, I will take this z-value and get an area, a percentage chance of occurring or probability of occurring, and compare it to my alpha. So before we do that, let's just warm our brains up for how to do this. Determine the p-value for a left-tailed test given the test statistic is negative 2.13. All they're really asking is this is negative 2.13. Go to your z-table and find negative 2.13 and tell me what the p-value is. So if you do that, you get it's 0.0166. Determine the p-value for a two-tailed test at negative 2.13. So if you are getting a two-tailed test for negative 2.13 or a two-tailed test, not only do I have this area, I have to consider the area on the other side that is that far out. So there's 0.0166 on the left, and there's the same amount on the right side. So you either double it or add it to itself. It's actually 0.0332 as a p-value. So it says use the problem from example 1. That is our seat problem, but do a p-value approach. Okay, so steps 1, 2, and 3 are exactly the same. We had h naught was p was equal to 0.5. H1 is p is greater than 0.5. Alpha is still our significance level, which was 0.05. Now we found the same test statistic, z naught, was equal to 2.78 from our previous problem. So how does this change when we're doing the p-value approach? We need to find the probability z is greater than 2.78 in our z-table. Now remember, z-table tells you to the left. We're looking for the area to the right, which means I need to look 1 minus the z-score in the table. Now if I look at 2.78 in my z-table, I see that this is 0.9973. 1 minus that is 0.0027. Now what do we compare the 0.0027 to? It's a probability. It's compared to my other probability number, which is alpha. Is 0.0027 less than 0.05? Basically, I'm saying, is my data rarer than my significance level? Is it more unlikely than my 5% chance? Absolutely, it's smaller. So this still lets us reject h naught, and it would still let us draw the same conclusion that we drew in the previous problem. It doesn't matter which way you do these. You can actually use one way to test to make sure the other way is working for you. You should still end up with the same conclusion. You should never be able to get one answer with one method and a different answer with the other method. And since we're not doing the confidence interval approach, that is it for 10.2.